Mr. Gazza here. Excuse me, homework 95. 95. So you definitely need a reference table for this, absolutely. Page 16 of the reference table, and you probably need your notes too. Terms we use to describe how a mineral breaks are cleavage and fracture. You probably know that by now, by this point. Cleavage or fracture. Minerals resistant to being scratched is its hardness. That's what hardness is. You probably know that as well. The diagram above, is a model of A. See the silicon, oxygen. This is in the notes. It's on the first page of the notes. You can see that silicon, oxygen, tetrahedron. Here's an example of it. Silicon, oxygen, tetrahedron. So that's choice B. Choice B. Which mineral contains millions of the molecules shown in the diagram above? Fluorite, sulfite, pyrite, or quartz. Which of those four? Hint, composition column in reference table of the reference table. So, page 16. You want to go to the composition column, and because this is Si, silicons and oxygens, it's Si04, this is, but you have to have minerals that have silicon and oxygen, and if you were to look through all of those, go through each one individually, fluorite, sulfur, pyrite, quartz, you will notice quartz, SiO2. Okay, the other ones don't have silicon and oxygen in it, so that's how you get that answer of quartz. Garnet, metallic or non-metallic luster. Well, you got to go back to the reference table. It's not something you're supposed to really know. Look around here till you find the name. You will find the name garnet right there, and then you will find it to be in the non-metallic section of the reference table. So the answer to that is non-metallic. Non-metallic. 6. This mineral here, I have a picture of it, will bubble or fizz when acid is dropped on it. Its hardness is less than 4. It's non-metallic and has cleavage. Name this mineral. So if you look here too, you see the cleavage. It definitely has a good sort of cleavage in 3 directions here. And notice these are not right angles. This is not right angles, so it's not cubic cleavage. And the answer to this is going to be what it says, non-metallic. It's one of these. Hardness less than 4, so now it's going to be one of these. It has cleavage, and you look around and you will get the answer to be bubbles with acid. That's the rhombohedral cleavage. Okay, that's what's shown here, rhombohedral cleavage. Okay, so the answer here is calcite. 7. Which has the highest hardness? Pyrite, gypsum, galena. So you have to just kind of look, and maybe you want to go through here and go through them all. Pyrite, hardness of 6.5, and for your own use, maybe 6.5. Gypsum, and the specific type is there, selenite gypsum. They're the same thing. It's just a type of gypsum. Hardness of 2. Maybe you want to write it on there as you look them up. Galena has a hardness. You got to find galena on there, and it may take you longer than it takes me. Galena, hardness of 2.5. So I'm looking for the highest hardness answer, pyrite. Okay. 8. This mineral is also called salt. I guess table salt is what we typically call it. Has a hardness of 2.5. Name it. And this is a good example of cubic cleavage. Right angle here, right angle there, right angle. All of these are very right angles. Right angles, and that gives you cubic cleavage. And a hardness of 2.5, cubic cleavage, food additive, melts, ice, salty taste. Halite is typical table salt. We will learn a little more about that coming up in a different lab. Does dolomite have cleavage or fractures? This is going right to the reference table here. Dolomite here, dolomite, go over to this column here. And if you look on the left side is cleavage, right side's fracture. Dolomite's on the left side, therefore dolomite has cleavage. This is just kind of really straightforward questions using the reference table. Which mineral is magnetic? Halite, magnetite, potassium, feldspar. Well, I would just look through each one. Halite, same thing about being magnetic here. It doesn't. Halite, magnetite, potassium, feldspar. Magnetite, or it does say magnetic, so that jumps out at you. It's magnetite, hence the name also. And potassium feldspar says nothing about being magnetic, so magnetite What am I doing? I'm doing magnetite, right? Not magnetic. 11. This mineral has a high hardness, has fracture, and is non-metallic. It does not contain iron. Name it. That's a picture of the crystal of it. It shows broken, how it's fracture. A high hardness and non-metallic. So high hardness we're going to put kind of down here. And it has fracture, so it's one of these. It does not contain iron. Not contain, I use the word iron. Iron is Fe. Okay, so of these three, olivine, that does contain some iron, Fe. Garnet also contains Fe. So the answer is going to be quartz. That's the hexagonal crystals. This is a little maybe hard to see from the picture. So the answer to that one is quartz. Okay, that's the first side. Your fingernail has a hardness of 2.5. That means approximately. Which mineral can scratch your fingernail? Which can scratch? So I want something that has a higher hardness than fingernail. Look through all the hardnesses. Graphite, you'll find right here, hardness of 1 to 2, not higher than 2.5. Pyroxene has a hardness of 5 to 6 in that range, so that should definitely scratch your fingernail. Talc, hardness of 1, can't scratch your fingernail. Pyroxene. Okay. Which mineral is used in pencil lead? That's where you're going to find this column here. We don't really use it in the lab. Uses here. Okay. And if you go through, it gives you choices. Quartz, olivine, graphite, pyrite. You will find that graphite says pencil lead. So the answer to that would be graphite. Which mineral is often green in color? So you look through olivine, sulfur, galena, look through them all in the common colors. And the only one that mentions green of those three is olivine. Green to gray or brown. Usually has a greenish tint to it. Olivine is olive green. Is a little phrase that could help. This dark colored mineral is non-metallic, has a hardness between 2 and 4, and has cleavage. It breaks into thin sheets. Name this mineral, and it said dark colored. So you're going to get in here, what did it say, 2 to 4. Hardness of 2 to 4 with cleavage, so it's in this range here, 2 to 4. It has cleavage. It breaks into thin sheets. This is flexible in thin sheets, as is this flexible in thin sheets. So muscovite or biotite mica, the difference is biotite mica is black to dark brown, muscovite mica is a lighter colored one, so the answer here should be biotite mica. The atomic structure of a mineral is, let's see, how its atoms are arranged. Know that. What is your birthstone? So what month you're born in gives you the birthstone. It will be different for everyone depending on your month of your birthday. Let's do a few more of these. Write the name of the mineral. Reference tables needed. I will just let me go through some of these here. Here, use the reference table. Figure these out. I'll give the answers just so you can check to make sure you're on the right track. Olivine. Talc. If you're getting any of these wrong, I'm trying to save some time here. Galena, selenite gypsum. If you're getting any of these wrong, go back and see what you did wrong. That is key. This is to help you. Hardness around 7, usually red in color. Fracture non-metallic glassy. That's garnet. Can either have metallic or non-metallic luster. Okay, this is in the luster column. Either. Sometimes this is, there's always exceptions to rules, and nature is very common. That's the case. So hematite can be very different. It can have higher hardness or lower hardness. It can be either metallic or non-metallic. So that is hematite. Okay, 24. Bubbles in acid only if it's powdered. Hardness of 3.5. So bubbles and acid when powdered. It doesn't say only here, but that's kind of what that implies. Bubbles with acid and powdered, and we will be seeing that in class. If you want to see it, I know I have a video that's called like the Fizz video or something. Fizz. Minerals, bubble and acid. I encourage you to go over and watch it. Non-metallic, pink in color. So this is, look at it, it gives a formula and everything. So that's potassium feldspar. And it's also called orthoclase, is sort of another name for it. This here is where people get stuck. Use page 1 of your reference table to match the letter to the chemical element. And elemental composition of Earth's crust by mass. Mass is by weight, as opposed to volume, which is sort of how much space it takes up. And I added a note, composition by mass, because oftentimes people don't read this thoroughly enough. So, A, B, C, D, this is the pie chart of sort of what Earth's crust is made of. If you look at A, it's showing A is 6%. What makes up 6% of Earth's crust? So you have to really know where to look. Okay, you look here, crust. Okay, these are the elements, this is the crust, this is mass, this is volume. What's 6%? Okay, so you got to use a little thinking here. It's this. 5.6 would round to 6, so it's going to be iron for the first one. Okay, and you could do this Fe, which is iron. B, 8%. Let's see, B, 8%, 8%. Okay, 8% right here, aluminum, Al is aluminum. C is 47%. What's 47%? I'll go back to here, 47%. And you know what? This is off a little bit. But this is where a little common sense comes in. That chart is a little different. Some of these charts vary a little bit. But this is 46, but that is really going to be your best answer. Hopefully you could sort of deduce that. That's what we're going to. Use common sense. Oxygen is the best answer. It's the biggest piece of the pie, and most of Earth's crust is actually composed of the element oxygen. Oxygen. O. D is 28%. What here is 28%? If you look right there, silicon. And now we're back to silicon and oxygen are the main components of Earth's crust. Okay? So, there we go. Homework 95. Hopefully you did well on that. Mr. Gazda, signing off. Thank you.